Welcome back to the Scotti-BYTE channel, and this is Scott. So in LXD Step by Step, we installed an Ubuntu server, we configured a bridge, and then we installed and configured the LXD server. We also created a LXD container on your main LAN using that bridge, and also a LXD bridge profile. What should you do to begin using your LXD containers? This tutorial addresses some of the basic commands that you should know. In the LXD step-by-step video, we used Ubuntu to create our first LXD container. And here you can see the command LXC image list images with a colon on the end shows all the various other types of images that we could have used to create a container with. And as examples, we have Alma Linux, we have Alpine Linux. We scroll down here in the list and we have something called Alt Linux, and we also have, believe it or not, Amazon Linux, whatever that happens to be. There's a couple of Arch containers, CentOS, even BusyBox, of course lots of Debian and Fedora and CentOS, and the list goes on and on. There's Gentoo, there's Kali, and there's Mint. So really you have a wide variety of choices for the various images that you might want to create a LXD container from. Since that listing was somewhat of an eye chart, in the show notes I'll include this small script here, and this script simply lists out the alias of all the different choices for operating system images that can be used to create your LXD container. And as we scroll through this list, you can see that there is a pretty broad range of options available. As I mentioned earlier, one of the beauties of creating a LXD container is that you're downloading a full image from a LXD repository, and for that reason it's really very quick to create and launch a container. And the LXC launch command not only downloads the container, but it also starts the container. In this particular case, we have LXC launch images :Ubuntu /manic, and I'm calling the name of my container test. Manic happens to be the keyword for Ubuntu 23.10, which has not yet been released. And if I do a LXC list here, you can see that it is up and running, and there is our container. So you'll notice that when I created and launched and started this container, it created an address on the local LAN, and that's not really what I wanted to do. I wanted to create this container and bridge it to the main LAN like I did last time. And normally you would have to go out and issue the commands at the time that you launch the container, but we can go back and make modifications to it with the command LXC profile assign, and the container we want to modify is test, and I'm saying use the default and the bridge profile. Now the default profile is included by default. However, when we assign a new set of profiles, if all I say is just assign the bridge profile, I'll actually get an error that says invalid expanded devices, failing detecting the root device. And as I had mentioned in the last video, the default profile specifies the storage pool where the container is stored. So we want to go ahead and say default, bridge profile, and it accepts that. Now if we clear our screen off and we do another LXC list, here shortly we'll get an IPv4 address which will be on the main LAN. And after just a few moments, if we do another LXC list command, you can see that I'm have an address of 172.16.1.60, and that address is on my main LAN. There is also a command called LXD init, and the difference between a LXD init and a LXD launch is that LXD init creates the container but does not start it. So in this particular case, I'm doing a LXD init, Ubuntu, and we're going to make it version 2204, the jammy release, which is the latest LTS release. And I'm going to say test2 is the name of the container. I'm including the default profile and also the bridge profile, and also I'm including a switch called boot.autostart equals to true. And what that does is anytime that the LXD host is booted, it will also start this particular container. So when I hit enter, it goes ahead and creates the container but does not start it. And if I do LXD list, you'll see that the test container here is still up and running. Test2's been created, but it stopped because we used the init command and not the launch command. You can list basic information about your container with the command LXD info test2, and here it said that test2 is currently stopped. The type is a container, and it's giving it the x86-64 architecture because that's the platform I'm on, and it also gives you the creation date. If we do a LXD info on test, the first container we created, it gives us a long list of information, and the reason for that is because the container is up and running and it can actually see things associated with it. It will tell us how many processes it has. It'll tell us the disk usage and the memory usage and the Ethernet device, and basically all the things that you might want to know about the container. Another command that we can use to examine how a container is set up is the command LXD config show, and here I give the name of the container test2. So here you can see that I have boot.autostart equals to true on the test2 container. You can see the architecture, the description of the container, and several other settings on that particular container. We can perform the LXD config show on the test container as well. And the other thing that I want to point out down here is you can see which profiles are applied to this particular container. As I mentioned earlier, when we did the LXD init on test2, it did not actually start that container. So we can do a LXD start test2, and it will go ahead and start up that container. So now both test and test2 are started. One of the powerful features with LXD containers that you don't particularly have with virtual machines is the ability to modify a LXD container while it's running. So in this particular case, I have a LXD config set test2, the name of the container, limits.cpu.allowance equals 20%. And what that says is that this particular container, when it's under load, is not allowed to consume more than 20% of the host CPU. And then I leave a space and I say limits.memory equals 4 gigabytes. And that means that at most, this particular container can claim up to 4 gigabytes of memory on the LXD host system. Now it's worthwhile pointing out, if your application needs more than 4 gigabytes of memory, like if there's a database running that requires more resources, it's possible that it may fail because it may have insufficient memory. But realize that these things for CPU allowance and limits.memory, they serve as caps for resources, and it gives you options. To see what settings we've made on this container, we can do LXD config show test2. And if you look down on the list, you will see that there is now a limits.cpu.allowance set at 20% and a limits.memory set at 4 gigabytes. Suppose we wanted to remove the memory cap from the test2 container, we could do a LXD config set test2 limits.memory and simply put an equals sign. You could then go back and do a LXD config show test2, and going down in the list you would see that there is a limits.cpu allowance at 20%, but the limits.memory is no longer a setting. If we go back and do a LXD config show test on the first container that I created, something else that you'll notice is that the image description normally contains the OS that we created it with. In this particular case, Ubuntu Manic for the AMD 64 architecture. And I remind you that Manic is the not yet released Ubuntu 23.10 that will be released in October. So you'll recall that we edited the container or modified the container with the LXD config set test2, where we added limits.cpu.allowance and we added limits.memory. And there are many other parameters, and you can also do a command called LXD config edit test2, in which case it goes into the nano editor and it shows you a configuration file where you can add and remove anything from it here as well. And when you exit the editor, it will go ahead and save this for you. Now, I might point out that if you make a mistake in here, for example, I'll spell the word limits incorrectly, and if I do a Control O and enter and do a Control X to exit the editor, it'll say that there's a configuration parsing error and that you can't do that. And so if I hit enter, it'll go back into the editor once again, and I can go down and correct my error. And once I do that, I can remove the limits.cpu.allowance, or I can just go ahead and save it out the way it is. So I'll just save it out the way it is with Control O and hit enter and Control X to exit the editor. And since there's no syntax error now, it correctly exited the editor and made the change that I had requested. So really, there are lots of other parameters that you can configure with LXD, and I also have a video called LXDware LXD Dashboard, and LXD Dashboard is a very good graphical user interface for the creation and modification of LXD containers, and I encourage you to watch that video. But for illustration purposes, I've gone into our test2 container we have here and clicked on the configuration tab, and you can see our CPU allowance here. Remember that we cleared out our memory limit, so there's nothing in this particular location. We have a lot of other settings here, and you can look down that list. You can also click on the edit option, and it will let you go in and edit any particular setting that we might want to add into our LXD container configuration. If we look at our test and test2 containers, we can do a LXD list, and notice that they're both being offered on the main LAN in virtue of the bridge profile. So one of the great powers of LXD containers is because we bridge them to the main LAN. If we want to have a container that offers Docker inside of it, we don't have to worry about a conflict with port numbers for other Docker containers, because we can have one Docker container, or one Docker application, I should say, per LXD container, and that way each Docker would have its own dedicated address. But before we can do that, we have to allow LXD to configure Docker inside of the container, or allow it to be configured inside of the container. And we can do that with the command LXD config set test2 security.nesting equals to true. And what that does is it allows us to be able to install Docker inside the container and have it run properly. If you don't do this, you will end up with errors when you try to install Docker inside of a LXD container. In order to connect to a container, we can use the command LXD exec test2 bash, which will enter the bash shell. And you could enter other command interpreters if you had other than bash installed on your particular container. So we can do an exit, and an easier way to get into the container might be LXD shell test2, because it's a little less to type, but it does exactly the same thing. After you enter a newly created container for the first time, just like if you create a brand new virtual machine, you're going to want to do an apt update. Notice that I'm not doing a sudo apt update simply because when you connect to the container, it goes ahead and connects you to the root account. So I can do an apt update on the container, and it will update to the latest version of the repository. And if there are any things that need to be updated, in this case it says 9 packages, I can also do an apt upgrade, and I'll put a -y on the end to avoid having to answer the question, yes, I really want to do the updates. So it completes that, it performs the updates, and it performs the upgrades of all packages. Now that I've performed the updates to this particular container, one of the things I always like to do is to add a user account. So I could do add user Scott, because by default we don't have a user account in a LXD container other than root. So I go ahead and create myself a Scott account, and then it may be handy that I provide Scott sudo privilege, so I can do a user mod -a capital G sudo Scott. And then of course I could move over to the Scott account if I wanted to with an su space dash space Scott, which moves over to the Scott account and also moves over to Scott's home directory. And if I do a pwd, you can see that I'm in /home/Scott. I'm going to go ahead and exit back to the root account in this particular case. So one nice thing to do with any Linux release is to do an lsb_release-a to let us know what particular version we're running. In this case, we know that the test2 container is Ubuntu 2204, codename Jammy. So now let's go ahead and install our Docker with the script on the Docker website, which is this simple curl script of get.docker.com. It'll go ahead and execute the installation of Docker. At the same time, I might want to also install Docker Compose with an apt install docker-compose, and I'll tell it yes, and it goes off and installs Docker Compose. Now once we've done that, one best practice you also may want to do is to do a user mod -a capital G Docker Scott, thus putting Scott in the Docker group, and that will allow us to issue Docker commands from the Scott account without having to use sudo. So let's go install a simple Docker application. And if we do an SU over to the Scott account, I like to, as a best practice, create a folder for my Docker application. So I'm going to do a make dir, and in this case we're going to install open speed test. So I'll go ahead and do an make dir open speed test, and then I'll cd into open speed test. And you can see in this particular case, if I do a pwd, I'm on the Scott account, so we're in /home/Scott/open speed test. Now I'm going to do a nano on a docker-compose.yml and go ahead and paste in the very simple open speed test YAML file. All it is the name of the image, open speed test, and then it has 2 ports, and the first port inside the container is port 3000, which really is the non-SSL connection to open speed test. And then if you had this thing behind a reverse proxy, or you had an SSL certificate assigned to it, then most likely you would be using port 443 to connect to it. But we didn't have to leave the ports at 3000 or 3001 because we could use the commonly used ports of 80 and 443. The reason for that is because the LXD container that we're running has its own IP address, and this is the only Docker application running on it, or for that matter, the only web application. So now I do a Control-O, I hit enter to write the file out, and a Control-X to exit the editor, and then I do a docker space compose up -D, and it will go ahead and launch that speed test container, getting all of its components, and then finally starting the application container. In order to find the address of this container, of course, I can do either an IPA from inside of the container, and if I look down, I can see that Ethernet 0 has an address of 172.16.1.108, or I can exit out of the Scott account, exit out of root. Back at the LXD host, I can do the command lexc list, and again I can see that test2 has an address of 172.16.1.108. Now something I also want you to notice is because we have Docker and a Docker application installed, we have other network interfaces on this particular container. So now I go ahead and open a web browser, and I paste in the address 172.16.1.108. I hit enter, and it goes into the open speed test application. And of course I can click on this, and what this is doing is it's doing an open speed test from my desktop machine back to the machine that's running the LXD container. It turns out that my desktop machine is actually my LXD host, so it's doing a LXD host to LXD host configuration. And since the NIC is a gigabit NIC, we're going to have a gigabit speeds in both directions. So you can see that the open speed test is actually working and running inside of a Docker container, which is a LXD container for Ubuntu 2204, which is offered out onto my LAN with its own unique address of 172.16.1.108. And the beauty of this is that the Docker container was able to use port 80 because it is running at its own address on that dedicated LXD container. So we can also stop our LXD containers with the command lexc stop test, and then likewise lexc stop test2. And now if we do a lexc list command, you'll see that both containers are stopped. You also notice it's taking a little bit longer to stop test2, and the reason for that is because test2 was actually running an application and it had to do an orderly shutdown. So now if I do LXC list, you can see both those containers are stopped. In order to delete a container, the container must be stopped, so you can use the command LXC delete test, and you can do LXC delete test2. And now if we do LXC list, you'll notice that both of those containers are gone. So this video was not meant to be an exhaustive study of all LXD commands because the LXD CLI is extremely broad. But what it was meant to do is to kind of give you some of the basics. And if you watch the LXD step-by-step video followed by this video, you have the basic commands in order to create and manage LXD containers. That being said, I encourage you to watch my other videos on LXD, and I probably have over 60, maybe 70 videos that are dedicated to very specific LXD functions. So in summary, LXD containers are initiated from images downloaded from the LXD repository and are faster because they do not have to go through an operating system installation process. LXD containers are more efficient because they do not virtualize any hardware like a virtual machine, and they share the kernel of the LXD host computer. LXD has a powerful CLI and also API. Watch my video entitled LXD Where LXD Dashboard to set up a web-based management interface for your LXD. Well, that's it for today. Please subscribe and like to the channel, and don't forget to hit that notification bell, and we'll see you next time.